The fourth family is graph-oriented store. The storage here is based on nodes, relations, and properties on the nodes and the relations. It relies on the graph theory and makes some pattern queries on the graph. So you provide this type of patterns in order to find information according to the way that information are joined together. So if you have different kind of database with many joins, it's all the more interesting to use graph-oriented stores. In order to be efficient and not to load all the graph at once, the way that they are computed is to load nodes which are required on demand. But the main difficulty is to know how to model the information inside the graph database. Just to have an example, we take the relational database and we can provide different nodes. According to here to different persons, there are nodes. And you can provide properties like status of the person inside the node, and you create different nodes here for the employers, and you can merge them according to which type of employer can be found inside the database. So you have the links between them, and these links can be typed also. So you have the employer link between the different nodes. But we can have different types of links. For instance, for Nicholas, you have the information that the employer is Esilf, but the ex-employer, the employer before, was CNAM. But we have also different links between nodes. It's vacation links for Centrale Supélec. And we can add other types of nodes where the different employers are located, for instance, for Paris or Gif-sur-Yvette. And now, according to this graph, you can put pattern queries. Here, we want to find persons who had two employers at Paris. So you begin with Paris and you make a pattern from location to employers or ex-employers that has Paris as a location. And that's it. You find the proper node of types person inside this database. You can find different types of solutions like Neo4j, which is the most known one, but also Azure Cosmos DB, which has different way to store information, or YonDB, or FlockDB for Twitter, and all the things you can do over this type of graph-oriented stores is network computing or provide recommendations about the graph. And you have to remind that there are not only social networks inside this type of database. You can find, for instance, the information for the hydraulic network for France, or you can have the electricity network, and you can have, for instance, the tourism information with the graph of tourists that are visiting different spots inside France, for instance.